Hello and welcome to our electric car workshop.
This workshop's part of the Southeast Engineering Festival, brought to you by Engineers Ireland, Carlow Institute of Technology and Waterford Institute of Technology. You can see more at engfest.ie.
What is an electric vehicle? Have you ever heard about self-driving cars or electric buses? Well, an electric vehicle is a vehicle that uses electricity for power. It was one of the first kind of transportation that did not use horse or human power. Electric trains and cars were built in 1830s. Cars powered by gasoline and diesel fuel became the most common for the last 100 years. The first known electric carriage car was built in 1837 by Robert Davidson and was powered by zinc acid batteries. So, as you might already know, batteries can generate electricity using chemical reaction. Davidson later went to develop an electric locomotive as well. However, it was quickly established that such battery-powered vehicles were not as economically viable as steam-powered vehicles, since the batteries were not rechargeable at that time. Now it's time to travel from the past to the future. Electrification is widely considered an attractive solution for reducing the environmental impact of road transportation. The most of the electric vehicles that we see on our roads are usually called BEV, battery electric vehicles, or electric vehicles, and use rechargeable batteries to work. But there are also other types of electric cars. Also cars that use solar energy with solar panel in order to work and move, and also a kind of car that use hydrogen. Behind all these inventions, ideas, and design solutions, there is engineering. So, what is engineering?
Engineering comes from the Latin
Ingenium.
which means engine and it also means brain. And it's also the root of ingenuity and smart thinking, which forms a huge part of what engineers do. So, engineers take ideas and they turn them into reality using science and maths and technology and imagination. Engineers are masters of problem solving, creative design. As a career, engineering offers a chance to make a difference to people's lives while you enjoy a dynamic and varied working life. Engineers are in demand across the world because they're essential to the growth and development of every country. Society depends on engineers to harness and control our environment, to provide us with essentials for living, like water, shelter, and power. In the past few decades, engineers have changed the world by helping to send astronauts into space, by mapping the human genome, and by creating the internet. Right now, engineers are working on innovative projects from solar energy to synthetic organs, from driverless cars, virtual reality headsets. There are many different branches of engineering, and engineers work in almost every industry in the modern world. A career in engineering offers people a chance to do interesting work with interesting people, to enhance people's lives, and to explore almost unlimited opportunities. Now, let's explore some real-life engineering. Over to you, Enrica.
Thank you, Ben. What is an electric circuit? Well, it's a path. A path for electricity. Or, I'd better say, a path for the electric current. As you can see from the sketch on the right hand side, if a circuit is closed, then the current can circulate in it. This is a main characteristic of the circuit. A circuit, in order to work, has to be closed. Here in the diagram you can see a source of energy where there is the plus and the minus, and you can see a light. The path, so the circuit, is usually made with conductive materials. A material is conductive if it can be a good path for the electric current to flow. Can you recall what we said a few seconds ago? A circuit to work needs to be exactly closed. So what is that component in the circuit that can turn on and off a light, so open and close a circuit? This kind of component, quite unique, is a switch. We can find switch everywhere for the lights of our rooms, in computers. So what is the job of a switch? Its job is to open and close the circuit. When the circuit is closed, then, for example, the light turns on. When the switch is open, so the circuit itself is open as well, then the light turns off. This happens because if the circuit is closed, then the electric current can circulate all around. If it's open, the current cannot move. The star of our electric car is for sure the electric motor. The electric motor is an electrical machine, an electrical component that can convert electrical energy into mechanical energy. Most electric motors can do so by a sort of interaction between the magnetic fields, so using magnets, and the electric current. Electric currents and magnets can make the motor move. We are going to use the motor to move the wheels of our car. Let's get started. This is all the materials that you have in your kit. There are some wooden sticks, a paper straw, some washers, rubber band, the motor, the battery holder, some sticky fixer, and the cardboard wheels. We also need the car template. You might also need some colors, scissors, and glue stick. It's perfect. But don't worry, as engineers are used to do, we can figure out how to do things also in different ways. So if you don't have the glue stick, don't worry, you can use the sticky fixer instead. Or as an alternative, you can also use tape. Our electric car needs a bit of preparation before to start. So as you can see, there is a battery holder that there is closed thanks to a screw. So ask an adult to help you in unscrew the little screw in order that you can be able to open the battery holder. This alternative is for teachers, so be very careful in doing this. So the screwdriver is better, of course, but if you have any other alternative, you can use the pin of the motor. But be very careful and gentle in doing so, because the pins are quite fragile and thin themselves. Before starting, we also need a piece of cardboard. You can cut a rectangle of 5 cm per 19 cm from any boxes that you have at home, like for example cereal boxes, pasta boxes. It doesn't have to be super strong, But yeah, if possible, it should be a little bit stronger than usual paper. I would suggest teachers to ask you to prepare this stripe in advance. Otherwise, you can also ask your teacher to stop the video right here and prepare your chassis for your car. Well done! Now you are ready to start to build your electric car from the kit. As you can see, you have a template. In the template, there are dotted lines that are black and some dotted lines that are red. You need to cut along the black lines. Here in this picture, they are marked with a solid line to let you know and show you exactly where to cut. If your template is now ready and your car is out of the A4 paper, now it's time to fold. This time we would need to follow the red dotted lines. Okay, remember, we are going to fold along all the red dotted lines. Let's start. You can do it simply using your hands, as I'm trying to show you right now. Remember to fold along every red dotted lines. No rush, it can take a while, just be patient and mind all the details, as engineers do. You can also use a ruler as a guideline. You can place your ruler near the red dotted line and fold the paper. It's optional, of course, but sometimes it can be helpful. If you need some extra time to finish this step, don't worry, just ask your teacher to stop the video for a while. In the next step, we are going to be designers. So these steps can require a bit of time as well, because now we are free to color and design our car. To do so, you just need to flip your template where there are no dotted lines marked, and yeah, be creative. You can use every color you'd like. You can use some patterns, some shapes. You can also add your name or a brand name. Now that your car is ready, it's time to use a little bit of glue. As you can see in the template, there are some areas colored in light gray, light blue. These areas are meant to be used to put some glue on them in order to build our car. So my suggestion is to go step by step. You can put your glue in one or two maximum area, then allow the pieces to come together and stick together using your hands to keep them in place. Once the glue is hard, then you can go and glue the other part of the car. So the first one is the front of the car, and now we can glue also the back. As you can see, I had myself flipping a little bit the template on the other side, but of course you can follow the colored area as well. I will show you in a second how the template will be once that all the areas are glued. Wow, it actually looked like a car, doesn't it? Okay, now we need to prepare our wheels. So make sure to pick the straw. It's a paper straw, and we need to cut it to cut 2 tubes from this straw. So pick the straw and also grab a pencil or a marker or a pen. Put your straw against your car and mark it in order to have the dimension that we need. We need 2 tubes of the same length. So I will show you how to cut the first one. Use the scissor and make sure to put your finger away from the scissor. You can use the first tube as reference. You can mark again your straw and cut. Be very careful, okay? There is no rush. Just do it piece by piece. And voila! Now it's time to prepare our wheels. To do so, have a look at this graph. You will need 4 cardboard wheels, 3 washers, 1 wooden pulley, the 2 pieces of straw, and the 2 wooden sticks. I should better say wooden axles. As you can see, in one pair of wheels there are 2 washers, in the other one there is 1 washer and 1 pulley. To assemble all the pieces together, use some sticky fixer between the pulley and the wheel and the washer and the wheel. Now that your 2 pair of wheels are ready, we need to mount them on our car. 1 pair will be attached at the front and the other one at the back. To do so, use a piece of sticky fixer. As you can see, the straw will be fixed to the car, so the straw won't move, while on the other end, the wooden axle in the straw will be free to rotate. So as soon as you have fixed your 2 pair of wheels, be sure to check if they are free to rotate. Another extra tip, remember, the pair with the wooden pulley has to be the pair of the front of the car. Let's mount also the second pair. Now you can flip your car and check if it can move. You can slightly push your car back and forth. Yeah, it's moving. Now it's motor time. So we need to add an extension to our motor. Be very gentle and okay, the motor is ready. Now it's time to prepare our circuit. For these steps, make sure that there is no battery in the battery holder. Okay? No battery. Why this is so important? Because anytime that we work on circuit and wires, the circuit has to be switched off, so without energy. Let's slip wire covers, 1 per each wire. As you can see, we have 2 wires attached to the battery holder. One is black and one is red. Black and red are 2 standard colors usually used in electric circuit. The black is usually the negative and the red is the positive. Before attaching the wires to the motor, we can give our wire a little bit of shape. So there is a metal part at the end of the black and red wire. We can shape it a little bit. Be careful. Okay, this shape can help us in connecting the wire to the pins of the motor. Can be a little tricky, but yeah, done. The shape of the wire helps us to fix the wire to the motor. Anyhow, they're not so fixed and robust. To completely lock them in place, we are going to use the wire cover, one per each pin. So you can push the plastic over the pin of the motor. Do it gently, because the pins of the motor are quite thin and fragile. But once it's done, the wire and the pin are perfectly in place. Oops! Okay, let's do it again. So, shape, and then everything in the plastic. So, both the wire and the pin of the motor. Everything in the wire cover. And yeah, the motor is ready. We can now test our circuit. So have a look at the back of the battery holder and make sure that the switch is off. Make sure that the switch is off. Now you can turn your battery holder and put the AA battery inside of it. Check where the plus and the minus go. The plus and the minus are the two poles of the battery. Okay, now that the battery is in place, we can close the battery holder. Okay, so take the lid of the battery holder and close it. It should stay closed as it is, without using its screw. But if an adult can help you, you can also put the screw back again and use the screwdriver. Anyhow, it's optional. Now we can test our circuit. Okay, so we put everything on our table and we can switch on. The motor will start to move. Switch off again. Okay, now we have to prepare our car in order to put the whole circuit into it. We need a bit of preparation, so look at the side of the car. There is a little rectangle shape. We are going to cut these two lines straight till the very bottom of the car. It's a little cut, around 2 centimeters. Now we can fold over that piece of paper. We need that space to connect our motor to the wheels. Now we are going to put our cardboard, do you remember the cardboard from the beginning of the workshop, inside the car. Use some sticky fixers or glue stick. It doesn't matter, it's the same. So now we are going to put our cardboard in the car and stick it very gently, because now the car is on the wheels, so everything has to be managed and handled with care. Okay, we can also assemble the motor. Again, use a piece of sticky fixer. You can also use tape. Peel it and place it exactly in the center of our cuts. As you can see, I'm going to place the motor on the cardboard near the cut, between the two cuts. And the black extension of the motor is out of the paper car. Now we can also assemble the battery holder. Again, just place a sticky fixer or some tape, quite sticky, and peel it and place the battery holder at the very back inside the car. Okay, here it is, nearly there. Again, be very gentle because now the car is on the wheels. Wheels are moving, the car is almost ready. How can we connect the motor to the wooden pulley? With a rubber band. In your kit there is a rubber band. So gently try to place the rubber band between the black extension of the motor and the wooden pulley. Be patient, it can be tricky, but once it's done, it would be real fun. So place the rubber band and try to link the wooden pulley to the motor. It could need a bit of adjustment, so if you see that the rubber band is too tight or too loose, you can adjust the position of the wheels, just moving very slightly the straw at the back of the car. Okay, so now it's the time for the final test. Put your car on the floor and switch it on. Whoa, that's amazing, isn't it? We used a particular type of motor that can work in both directions, forward or backward. So I'm so curious to find out what happened with your car. Is it moving forward or backward? Don't worry anyhow. If you want to change the direction, you just need to place the motor at the opposite side and switching the wooden pulley as well in order to connect the motor to it again. We hope you really enjoy this workshop. Share with us your creation. Use the hashtag engfest.ie.
This workshop's part of the Southeast Engineering Festival, brought to you by Engineers Ireland, Carlow Institute of Technology and Waterford Institute of Technology. You can see more at engfest.ie.